So welcome everyone to my next YouTube video from Cat Astro. As you can see, I've been playing with the title screen, and let's hear it from the animals. So let's talk about polar alignment. Quite possibly the most important aspect of astrophotography. I'm not going to underplay this. It's one of the most complicated and the hardest thing to master. But once you have mastered it, the options are endless. I mean, we're talking going from 8-second exposures all the way up to, I think my record is 15-minute exposures without star trailing, which is, for me, pretty amazing. So, what is polar alignment? And that I'm going to try and break it down to the basics. So, I said the basics. So here we go. So on the left-hand side, you see the moon. On the right-hand side, you see the moon. And in the middle, you are still here at 1700 hours, and you're still here at 2200 hours. You have not moved. The moon hasn't moved either, by the way. The Earth has rotated. Now, how do we polar align? We need to get this arc, this whole arc, aligned with our mount, not our telescope. Uh, Interesting. A few friends and colleagues have said, do I need to point my telescope? No, you need to point the mount. And you need to point the mount at the North Celestial Pole. So imagine there's a big line through the Earth, and it's the NCP and the SCP, South Celestial Pole. And how do we align with the North Celestial Pole? It's the bit at the top of, how do I explain this? Imagine you're standing on top of a massive football and you're looking up. When you're looking up, if you're in the middle of the ball, you're not turning. It doesn't look like you're turning. But if you're on the side, it's going to get pretty crazy. So you need to align your mount with the North Celestial Pole. How do we do that? We use the North Star, Polaris. Now, intentionally, I have moved the North Star from the left to the right a little bit. The North Star is not the North Celestial Pole. Let's get something very clear here. It's not the North Celestial Pole. Close, but by no means exact. In the South Celestial Pole, if I'm not mistaken, I think colleagues down there use the Southern Cross. They have less options, if you like, but they use the Southern Cross to basically polar align. So what you need to do, and as you can see, you are here, you need to get your mount perfectly aligned with the North Celestial Pole such that when you start tracking, your mount will follow the Earth's movement or move with the Earth. We're splitting hairs here now, but you need it to move with the Earth. Now, there's some really cool apps out there. This is my favorite, the Polar Scope Align Pro. And you can see very clearly on this app that the NCP is in the middle and the North Star, also known as Polaris, is quite a way above. And that's how you do it. So when you're polar aligning with the Quattro Plus or the, I don't know, the Skywatcher, HEQ5 Pro, you need to get the North Star in the same place as you can see on the app. It doesn't have to be, and it should never be in the middle. Again, I will stress this again and again. The North Star is not at the North Celestial Pole. It's quite a distance away. And just one thing before I move on to the next slide, the Skywatcher HEQ5 Pro has a perfectly good polar scope. Amazing piece of equipment. However, I struggled with it until I saw, I don't know, something on cloudy nights. I couldn't focus. And the reason I couldn't focus is because I wasn't turning the black bit at the end. Little twist. I would get my wife to help. She's got better eyesight than me. And then I realized that the black bit at the end of the poloscope that doesn't turn, it does. So for those of you with the HEQ5 Pro, um, give it a hard twist and you can focus. Anyway, so I did suck it up and upgraded to the ASIair, which does this amazing thing called plate solving. Plate solving is you still have to polar align. It is not free. You still have to polar align. And what it does basically, it tells you your margin of error. So you can see the NCP, North Celestial Pole, and you can see Polaris down the bottom. And you can also see your scores. Points don't mean prizes, but in this case, I was pretty pleased with this. Sorry about the image. Image is pretty shocking, but you can see I was bang on target. And a little bit I could have moved up, but I didn't. I mean, I shot the NGC 7000 for about 4 or 5 hours after this, and at 3-minute subs, it was pretty cool. So how do you polar align? Twiddly bits. It's all about the twiddly bits. So very basic. So on the left-hand side, you can see the degrees. So this is a very basic mount. But basically, it's all about in a bit, out a bit, up a bit, down a bit. Just keep moving it until you get exactly on target. It's fiddly. It's not easy. You're going to get eye strain. You're going to get cold fingers. I mean, here in Lower Austria, I think I had to clear the snow this morning. It's like -5. Um, but the better your polar alignment is, the better your imaging is. We don't want star trails unless we really want star trails, and that's a different topic. So left a bit, right a bit, up a bit, down a bit. I mean, that's pretty much it. And for those of you that are fortunate enough to have terrace, decking, whatever, paving slabs in the back garden, grab a marker pen, a Sharpie, or whatever. Yeah. So work on your polar alignment, and as soon as you get a felt tip pen or a Sharpie or a marker pen, whatever you call it in your country, and draw circles around the tripod legs. I mean, this has saved me hours, literally hours over the last couple of years. So when I'm imaging, which I hope to do in 3 hours, I will take my tripod out and I will find the black marker pen points on the paving slabs in my back garden, and I will position the legs exactly where they need to be. And from there, I can normally polar align in a minute, maybe 2. So, bit of a catastro top tip. It works for me. I'm hoping it might help you out in the future. And in the meantime, I need to have something to eat. Take care, stay safe. Winter is coming, and I wish you all clear skies. TTFN.